Hi, everyone. Welcome back to day two, and thank you so much for joining us today. I'm going to quickly go over the housekeeping announcements again before we begin. If you have any technical issues, please send a private chat message to Jenna Britt to troubleshoot. You can find Jenna at the top of the participant list in the host section. If you're having trouble seeing the presentation, please refresh your browser tab. Your chat tab will automatically be open to the general chat. Use the general chat for general discussion and words of encouragement for the speakers. Clicking the back arrow will take you to the full chat list where you can chat with anyone at the table you're seated at or privately with an individual in the lecture hall. Each panel will have a live moderated Q&A. There are two ways to participate in the Q&A. You can click on the Q&A tab and type in your question, making sure to specify who the question is for, or click the raise hand button to be brought on stage to ask your question verbally. If you see a type question you like, you can upvote it to move it upwards on the list. And please submit questions at any point during the panel so we can get to as many possible in the time allotted. If you'd like to exit the lecture hall, the link to the lobby is posted at the top of the general chat. And please also note the agenda icon on the top right side of the top bar. Open that to see the full event schedule for the day in your local time zone. Thanks again. We'll go ahead and begin with our welcome remarks.
Good morning, everyone, and welcome back to day two of our workshop on exemplary admissions practices that promote diversity in engineering. Yesterday, we had a really wonderful discussion. We heard from our first group of panelists, and we learned about the concepts of test optional and test blind admissions. We also learned about holistic and comprehensive application review in the admissions process. A number of reports were also discussed by our panelists, illustrating that standardized tests do not correlate well with student success and outcomes. High school GPA, preparation, and key experiences are better indicators of success at four-year institutions in the field of engineering. From our second group of panelists, we learned about various programs being implemented across various universities, including Texas A&M University, Cal State University at Long Beach, Rutgers University, and Iowa State universities to recruit, retain, and graduate diverse students. We learned that partnerships between two-year institutions and four-year institutions played an important role in student success. Dr. Ghoshani from Cal State Long Beach enlightened us with his perspective, and I quote, "No student is average. We must meet students where they are as learners and adapt services to help them excel." I could not agree more with Dr. Ghoshani. We then transitioned during the day into a series of breakout groups. And we asked all of you to answer the following four questions. How are the policies you heard about today affecting your work and institution? Number two, what policies would you like to implement? Number three, what barriers do you see to implementing these policies at your institution? And number four, how would you overcome these barriers? As it relates to policies, as a result of the pandemic, we heard that most institutions had extended test optional and in some cases test blind policies in their admissions process. There was a lot of interest in holistic and comprehensive application review and how that was producing potentially diverse student bodies. In addition, we learned about how some states offer a unique course numbering scheme that is consistent across two-year and four-year institutions. These states included examples, North Dakota and Florida. These made transitions to four-year institutions more seamless with an identical course numbering sequence and content. However, what also emerged in our discussions yesterday was a discussion about graduate admissions and how standardized tests like the GRE are used to admit graduate students or international students. The question that came up was, how could international students be properly vetted before being admitted to pursue graduate studies at U.S. institutions that does not have to count on standardized tests? So it raises another question at the graduate level. Some barriers that were discussed, we also learned about barriers affecting policy change, such as cultural issues between majority and minority communities and students that they serve, stigmas and perceptions about certain high schools, community colleges, and student readiness to learn. And then number three, effective communication was seen as a barrier with faculty and staff to help them understand the benefits and challenges of different admissions policies and the efficacy of those results. So we learned a lot yesterday. and day 1 of our workshop. Today, we are going to hear from 3 different groups of panelists focused on the following topics. Number 1, transfer programs that involve 3-year plus 2-year programs. This will be moderated by my colleague, Dr. Beth Myers from the University of Colorado. And then following that session, there'll be a session on best practices in admissions, which will be moderated by Dr. Andrew Williams from the University of Kansas. And then finally, wrapping up the day, another session on research in admissions, moderated by my colleague, Dr. Teresa Maldonado, who is the Vice President of Research at the Vice Chancellor of Research at the University of California System. So that's what we have for you today. And with that said, I would like to turn it over to Dr. Beth Myers if she is here.
Thank you so much. So this morning, as was just discussed, we're going to have a panel that focuses on transfer pathways and 3+2 programs. We'll have 4 panelists briefly present on their work, and then we'll open up the panel for moderated questions and answers. So please go ahead and post your questions in the Q&A box. And if you have a specific speaker you would like to address your question, please put their name in the question as well. I'll let each panelist introduce themselves, and I think hopefully they're getting up here on stage. So our first speaker is Dr. Brooke Burhane, Assistant Professor and Undergraduate Program Director from Florida International University's School of Universal Computing, Construction, and Engineering Education. I think your mic is off still.
Mic is broke. You just gotta click that microphone symbol.
Okay. Can you hear me now?
Yeah.
Hopefully everyone can hear me. I apologize for the technical glitch. I had 2 mute buttons that I was using at the same time. Good morning, everyone. I'm Brooke Burhane, Assistant Professor of Engineering Education at Florida International University. And I'm happy to be a part of this panel, happy to be a part of this discussion. So I will proceed with a overview of one of the studies that I'm leading at FIU. It is, as you can see on your screen, the Black Engineering Student Transfer Project, otherwise known as BEST. And I'll be providing an overview of 3 of our papers and projects that we're working on under this project. You can move to the next slide. So you can get a sense of our project team. So I'm the principal investigator, and I'm joined with a pretty diverse group of individuals, both from a number of universities. You can see them on your screen here, from higher education, engineering education, graduate as well as undergraduate students. Next slide. Generally speaking, the goal here is to, without reading from the screen, to understand what allows students who are broadly classified as Black, but also have within group diversity in terms of where they're born, both Black American and students from sub-Saharan Africa, what allows these students to be successful as engineering transfers. And so the questions really are center around this notion of what it means to be successful. And we define success as transfer, as well as persistence and retention once they do transfer. So the research questions really undergird what I just said. And the primary research methods that we're using for this study are interviews and focus groups. So it's largely qualitative, both pre and post transfer, as well as during transfer. So we've really talked to students along the pathway, whether they have or they intend to transfer or they have already transferred. Thus far, we've talked to about 20 undergraduate students. The majority of them are post transfer. The majority of them happen to identify as men. And that's certainly the racial and gender diversity is something that we are unpacking and can be discussed at another time. just to give you a sense of what motivated this particular study, the graphic here, which you can see to some degree, the font's a little bit small, and I apologize. As we look at the issue of transfer from community college to four-year institutions, Black students in particular, across most racial and ethnic groups, tend to fare the lowest in terms of their transfer rates. About 28% of all Black community college students do transfer. The graphic below that gives you a sense, however, of the potential for transfer. And I say potential because what is little known, I think, in most of the circles, at least that I've been in, is that very few conversations are happening around the number of students who are earning, say, associate degrees in engineering versus bachelor's degrees in engineering, who happen to come from underrepresented racial and ethnic backgrounds, or we might use the term Black, Indigenous, people of color, or BIPOC. So this graphic shows, and I'll just give you the number since you can't see, 14% of all AS degrees in engineering are awarded to Black students. Interestingly, about 20% are awarded to Latinx students. And that's interesting to me because those numbers really do reflect the US population. And so usually when there are conversations about how do we diversify, how do we broaden participation in engineering, the argument usually goes something like this. The US must become more competitive. The US must become, the number of students of color should reflect what they are in the general US population as we look at the number of students who are earning BS degrees. And while that certainly is true for students of color earning BS degrees, at the AS level, we already have parity. And so I think this is an untapped potential that we in the engineering community really should look at, because if we do have parity, if we see those same numbers reflected at AS degrees as we do in the US population, why don't we see more of those students transfer over and earn those four-year engineering degrees? And that's just something that is really undergirding what we're approaching this study with. And this is supported by the National Science Foundation. Next slide. So our first paper, and again, there's a lot of text here, so I won't read everything to you, but the first paper is really looking at the pre-transfer experiences of these students. And so our team set out to understand what allows these students to be successful and feel supported, if at all, at their community colleges. And so, not surprisingly, students talked about both faculty and advisors. And so, generally speaking, everyone who was discussed from the student's perspective really was a positive mentor, a positive source of support. So professors were described as impactful in a positive way, offering office hours. They were available to students. One of our students said, when we have discussions, the professors are very connected, going around and making sure that every student is picking up the subject matter. The advisors are generally described as knowledgeable and well-connected. I won't read that slide to you. You can sort of read it for yourself. But again, the students feel very supported, very privileged to be a part of their advising community. This is interesting because when we compare that to the narrative that we often hear in books like Talking About Leaving by Seymour and Hunter, and most of you all know that body, we typically hear narratives primarily around the four-year PWI context that students do not feel supported, do not have the ability to talk to their professors one-on-one. So we see it sort of a counter narrative to what we hear in the four-year college experience reflected in this two-year college discussion, which is very positive. Next slide. So this paper is looking at the actual process of transfer. And so how do these students describe the process of transferring from a community college to a four-year institution? So generally speaking, they talk about doing this work on their own. And so I've been citing Shuli Wang's work. Shuli's out of the University of Wisconsin-Madison. I look at her as a mentor. And she wrote a book a year or two ago called On My Own. And these students are really saying exactly that. So they are having to go to websites, driving to campuses, talk to admissions officers, really confused about the process because no one is really going to their door saying, how can I help you? How can I make this process more transparent, more cohesive? They're really trying to put the pieces together for themselves. And certainly some students are pointing to faculty or staff, but the majority of students have, and you can see that in the second bullet below on the lower left-hand corner, there are some staff, some faculty, but for the most part, these students are having to figure out this process on their own. And obviously that's not something that we would want to see. In the last slide. Finally, we call this next paper, What Happens Post-Transfer? So how do students adjust to the intensity and the culture of the environment that they transfer to? Well, they've talked about adjusting. finding, as one of our students said, exams are different. The exams are shorter. The difficulty is much harder. There are more questions. And you have to tackle these issues. And this is different from what they've experienced within the community college context. And you can see that those bullets below in the lower left-hand corner. And the third bullet there in the lower left-hand corner says, given the differences in the community college and the four-year setting, we recommend that students should be, and the outcomes from our studies say that students should be better socialized into campus norms and culture. So one of our students said that he felt like the amount of work you have to do by yourself is a lot compared to what you have to do at the community college. So it's really about identifying these norms and cultural issues that make the community college different from the four-year school. And with that, the last slide, I want to thank you for your time. Have a great morning.
Thank you so much for sharing your work with us. Next, we will hear from Dr. Nandika D'Souza, Professor and Associate Dean of Undergraduate Studies at the University of North Texas.
Okay, let's give this a shot. If my PowerPoint is on, oh, I don't think I have it right. Give me a second. Few technical glitch. Oh, I'm actually PowerPoint. Okay, are you seeing a PowerPoint? All right, welcome everyone. I am Nandika D'Souza, and I'm going to talk about our experiences from the state of Texas. And I teach at the University of North Texas, which is located in the Dallas-Fort Worth area. Our student population within the College of Engineering is in the order of 4,000 students. And we have a large underrepresented minority population. We have become this year an HSI program. You will see that effective 2018, we added a group called pre-engineering, and I'm going to be explaining a little bit more about that as I talk about our interventions. From our graduates, you can see that we graduate a large, substantial number of students. And our degrees are in biomedical, computer science, computer engineering, IT, electrical, materials, mechanical, and construction. The diversity, again, I actually think this is substantial. And we have just 17% is in the female population. But we do have a large number of Hispanic as well as African-American students. I will go forward and get to both our diversity issues, etc. But what I thought is I'm going to focus on the admissions. So the admissions in the College of Engineering, and let me bring this website on there. I apologize, I'm a little challenged today. There you go. So, all right. So we have in the state of Texas to help with the community college transfer, we have two things. We have the Texas Common Core numbering system, and that allows you to both search for schools, and you can compare schools, and you can search by course. So this allows you to find a course which are common to our degree plans, and it crosses all across the state of Texas. In particular to the College of Engineering, as well as a few other departments, the degrees are also, they have the Texas Transfer Framework, which is a really helpful system that allows you to what we call the field of study. So you have mechanical engineering in particular, I'm going to show you, you have these common core courses, and they would apply to the mechanical engineering degree plan. So you know within the options for your courses, you get both the physics math courses, but then you also get your freshman and sophomore engineering classes. This allows substantial amounts of support systems. What happens to students who enter our college is they either are admitted to the major program, and that is based on how they fit in a combination of math and composite scores, ranking in class, etc. But if they don't fit in, then they are placed in the pre-engineering program. And we have brought the pre-engineering program into the College of Engineering. And in particular, we have created a guided pathway that enables a student to start enrolling in classes, even if they are at the algebra level. You can pick your degree plan. You have a degree plan for pre-calculus or calculus 1. And we have the guided pathways for community colleges. And what we've done is we both identified, we have a group of colleges that are located in Dallas-Fort Worth. There are 7 of them. And we cull through their degree programs. We work with their transfer coordinators. And the most part, Texas high school students start out with the algebra level, and they have no problem with enrolling in classes, and they are aided by our field of study courses. So what we are promoting is the dual enrollment, which is as soon as the second semester, the sophomore first semester, they should start enrolling in UNT courses, and we color code the UNT courses green. This enables the student not to wait for the 2 years to start out in the engineering degree. They already know with the field of study that that is their set of courses, and they are able to graduate in a seamless way through the 5 years, which is a little challenging if someone waits for 2 years and then starts out in engineering. And this one, mind you, is the algebra version. Of course, if you start with the calculus version in the community college, you would actually have a shorter path to graduation, which would give you the same 4-year FTIC degree plan. So that is our approach to doing it. And we try to also identify the community college. So we build a relationship that is seamless between their originating college as well as their destination college. And what are we really, I just wanted to leave you with a critical issue that is facing our students is that it is pretty unreasonable that our students would have a low success rate if they don't have, if they do not have, if they come from a community college and they start out in pre-major. Pre-major is a sign that they haven't finished calculus. So our goal in this effort is to reduce the number of students who come to start in an engineering degree plan and don't have that starting first semester course of the Calculus 1 course. And that's what I have for today. And you can reach me for further questions. Thank you.
Thank you for sharing the way you've approached transfer with your community colleges. Next, our next speaker is Dr. Stephanie Luster-Teasley, Interim Vice Provost for Undergraduate Education at North Carolina A&T University.
Thank you so much for this invitation. It's definitely an honor. It is my pleasure to present to you the activities that we do at North Carolina A&T State University. At North Carolina A&T State University, I was recently named the Vice Provost for Undergraduate Education. Prior to becoming Vice Provost, I was Professor and Chair of the Department of Civil, Architectural, and Environmental Engineering. So my presentation today will give you an overview of my experience as a chair with students that entered our program in 3+2 programs, and then now as the Vice Provost with students who are entering STEM careers and academic disciplines in 3+2 programs that come to North Carolina A&T. To give you an overview of North Carolina A&T, we are the largest HBCU. A&T is a land-grant doctoral higher research activity university. We were created by the Second Morrill Act in 1890, which expanded the system of land-grant universities to include historically Black institutions in states where segregation denied minorities access to land-grant institutions as established by the First Morrill Act in 1862. Our mission at North Carolina A&T is to focus on STEM-related curriculum. However, we also include all other majors and disciplines. For our mission, North Carolina A&T advances knowledge through scholarly exchange and transforms society with exceptional teaching, learning, discovery, and community engagement. In 1890 land-grant doctoral institution with a distinction in STEM and commitment to excellence in all disciplines, North Carolina A&T creates innovative solutions that addresses and challenges the economic needs of North Carolina, the nation, and the world. Our university consists of 9 colleges. We have the College of Agriculture and Environmental Sciences, Arts, Humanities, and Social Sciences, our Willie A. Deese College of Business and Economics, College of Education, College of Engineering, the John and Kathy Harrison College of Health and Human Sciences, College of Science and Technology. We also have a joint school of nanoscience and nanoengineering, and our graduate college, of which 3+2 programs have students that are represented in all of these colleges. Our enrollment includes over 12,800 students with diverse backgrounds. The majority of our students will come from North Carolina. However, for our engineering program in particular, we have students who come predominantly from the East Coast and then also the West Coast. So our engineering program has a tendency to have very diverse numbers of students that transfer into our program. North Carolina A&T is the #1 producer of undergraduate engineering degrees to African Americans. We're the #1 producer of degrees awarded to African Americans in North Carolina, the #2 in master's degrees awarded to African Americans in engineering. Our campus offers 54 baccalaureate degree programs, 29 master's degree programs, 9 doctoral programs to a student population of over 12,000 students. And we are classified as a doctoral university with high research activity totaling over $64 million. To speak to you today specifically about our 3+2 programs in the College of Engineering, our engineering programs are led by Dean Robin Koger, of which we have chemical, biological, and bioengineering, civil, environmental, and architectural engineering, computational science and engineering, computer science, electrical and computer engineering, industrial systems engineering, and mechanical engineering. Our College of Engineering enrollment is featured here on this slide. We have approximately 1,800 students in our College of Engineering, which includes both graduate and undergraduate programs. If you look at a breakdown for our demographics, we are predominantly African American, of which our population is about 1,300 students. We have other diverse groups that are represented also, and hence our knowledge in advancing transfer programs so that we can invite students to North Carolina A&T. I was invited to specifically speak about 3+2 programs. So 3+2 programs are transfer articulation agreements and MOUs between colleges and universities where students will attend their first institution for 3 years to focus on general education and STEM courses such as mathematics, biology, and then they can transfer to a college or university with an engineering program to complete the last 2 years of study. The students will receive their BS degrees from both institutions upon graduation. A&T's College of Engineering has a number of consortium agreements and MOUs with various universities. Some examples include Spelman, Morehouse, Clark Atlanta, and Bennett. All of these colleges will have students that will start programs at the initial institution, and then they'll finish their last 2 years at North Carolina A&T to receive their engineering degrees. As an administrator, I wanted to discuss some of the considerations that you need with 3+2 programs because they are a way that you can increase the number of transfer students. Making sure that the MOUs are formally signed and agreed upon for the way that the two institutions will work together. Ensure that there's an ease of transition for the students between the schools, because of course there will be cultural differences and things that the students need to adjust to their second institution. Transfer articulation courses from the first institution to the second institution must be established so that the students are not burdened by the need to check on their courses between the two universities. And it's also beneficial to have a liaison between the schools so that the students form a pipeline between the two programs. Culturally, there can be differences between the first institution as compared to the second institution. So making sure that your students have a sense of belonging is very important when they come to you for your engineering programs. Making sure that the students are able to form cohorts within the department, the college, and then also the university also helps their ease of transition and their progress towards the degree. The research that my group does with Iowa State University looks at microaggressions that impact students that transfer between programs, or also students who are in underrepresented groups at either HBCUs or PWIs. In particular, when you're considering 3+2 programs, think about some of the experiences that your students that transfer in may undergo, such as micro-insults, micro-invalidations, and micro-assaults. All of these are things that impact the student's ability to really fit in with their new university if they are part of a 3+2 program. So when looking at 3+2 programs for a university, of course, the goal is to increase the number of students that are present by having a pipeline between two universities. However, it is really important to make sure that you have a supportive and inclusive environment where the administrative supports are in place, your transfer articulation of courses are clear, the cultural differences between the first and the second college and university are clearly understood and addressed to ease with the diversity and inclusion of your students. Thank you.
Thank you so much for sharing some of your work. Our next presenter is Dr. Robert Pyrie, Professor of Mechanical Engineering at North Dakota State University. We can't hear you quite yet.
There we go. Good morning. If I get my slides up and we're ready to go, North Dakota State University. So we're going to talk to you about a 2+2+2+ infinity program, and we'll talk a little bit about that later on. I want to thank NSF for the support on this operation. Without it, it'd be crucial for us. Today's agenda, or the story we're going to go through, who we are, who they are, what we're trying to do, why we're trying to do it, how we're going to get there, some of our successes, where we need to go, or maybe things you might be able to walk away with. One of the things that I've come to realize talking with Native Americans is that they need to know who's speaking. They need to understand where the conversation is coming from. So usually they introduce themselves first. It's usually done in their native language, and since I'm not very good at Italian, we're going to have to use English on that. So the idea is that the story is related to the person telling it. My grandparents all came over on a boat. Why did they do that? Because they were trying to find a better life, and so forth and so on. I think I've done well by them. I'm the first four-year engineering graduate. I'm the first PhD. I'm the first retired lieutenant colonel in the family, first Air Force Academy instructor, first professor, and first to have a sabbatical to a tribal college. Who are we in terms of where we are? Here's a map of the state of North Dakota. On the north end there is Canada. The yellow areas are the tribal reservations. We have connections with all four of these reservations: Spirit Lake, Turtle Mountain, Fort Berthold Reservation, Standing Rock Reservation. Turtle Mountain is probably one of the smallest reservations in the U.S., and Standing Rock is one of the largest. You're only seeing half of it there. The other half is in South Dakota. I had to include a tremendous picture of our climate in North Dakota. This was last week. No, it wasn't last week. It was winter. One of the things we do with this outreach is we actually use mentors on site. So we have a number of colleagues. I have a number of colleagues at the different institutions. Austin, Ann, Josh, Mike, Carl, and myself work at it. We have a common curriculum, common numbering system across the state. Course delivery and scheduling is done on a common basis. We all talk to each other, and we have students from each of the sites. Otherwise, it would be prohibitive economically to do so. The thing we try to emphasize is personal connections. That's who we are. Who we are also requires that I read this land acknowledgement statement. We collectively acknowledge that we gather at NDSU, a land grant institution, on the traditional lands of the Ochete, Shiwakan, North Dakota, Lakota, Nakota, and Anishinaabe peoples, in addition to many diverse indigenous peoples still connected to these lands. We honor with gratitude Mother Earth and the indigenous peoples who have walked with her throughout generations. We will continue to learn how to live in unity with Mother Earth and build strong, mutually beneficial, trusting relationships with indigenous peoples of our region. And I don't know if you were able to hear that, but Ochete Shakawi was what was said by the speaker there. And what we're doing is, I'll reference that a little bit later. Let me get back here. And so who are they? Well, they're the first residents of this land. Perhaps 50,000 years before we ever stepped foot on it, there were peoples here. And as you can see from the map, there were a lot of peoples here, upward of about 50 million. It's kind of interesting in all the educational charters put forward by the King of England, those supporting Dartmouth and Harvard and Columbia, all included Native Americans in the education. When we won the War of Independence, things started to change. The history with the U.S. for indigenous peoples has two major issues: the land and movement on it. That caused wars. Wars ended in treaties. Treaties led to sovereignty. And that's a problem. I mean, I don't think there are many of you out there that are teaching to a population from a sovereign nation that is just down the road a piece. So the other thing we've had to do is overcome boarding school issues, which actually is a negative connotation to education off the reservation. So what are we trying to do? Well, what we're trying to do is stop that. And what that is the dropout rate after first year. Most admission practices are after highly qualified students. That means to say students that you know will be successful. That leaves a lot of people out of the table. It's never about lowering standards. It's about improving coaching for these people. The diversity can help us mirror some different things. What we're trying to do is not change them to mirror us, not make white engineers, but to make Native American engineers. Money is not enough. Money is necessary, but it's not sufficient. Once we admit them, we can't forget them. We have to work with them. Why are we doing it? That black picture you see there is a nighttime view of North Dakota. The two bright spots on the right side are Fargo, North Dakota, and the brightest site up in the upper area is Winnipeg. That big cluster of light spots where my pointer is, that's actually the Bakken oil fields. So we've got air pollution and oil going there. We've got a map of the Missouri River here, and there are a number of containment areas on it at Fort Peck, at Garrison, at Oahe, Big Bend, and there means to be about 6 tribal reservations along that line. So it's an opportunity to aid indigenous communities. It's also an opportunity for cultural breaks. This is how we do it: cooperation between the tribal colleges in North Dakota State. We have advisory councils, engineering advisory councils, cultural advisory councils. We keep culture in part of the mix. How are we getting it done? Making it personal, making it relativistic, interpersonal relationships, build a cohort, demonstrate support to those cities, and go through. Some of our successes: we've had about 40 students touched by this. That's produced 11 bachelors of science of engineering. Of those, 2 went on to master's degrees. 2 of those that have graduated are working with the tribes. We've got 1 actually teaching at a TCU and making an influence in their communities. We need to treat Native students as individuals, just like all of our students. They want to join our professions, and we should celebrate that, but at the same time recognize that there are different reasons for it, and we need to meet them halfway. It's not an idea of meeting some sort of entry-level activity, but to let them in if we truly want to diversify. And with that, I really thank the Academy of Engineering for this opportunity and appreciate it greatly. Thank you.
Thank you so much. I will now invite the other panelists to go ahead and turn on their cameras so that we can start the Q&A session. Again, if you have questions that you would like me to ask to the panelists, please go ahead and put those in the Q&A section, which is at the top right of your screen. But I will go ahead and start with a question, and then I'll move on to those Q&A. So there was mention a couple times of the fact that certain states or systems have consistent course naming or numbering. So and whoever wants to take this first, go ahead. I don't have this for a particular, but how does that affect a student's ability to access and transfer to another institution?
Thanks, Beth, for the question. I will say that I'm new to the state of Florida, but it was mentioned earlier that Florida has the common course numbering system. So I reached out to an advisor who formerly worked in the state of Florida at UF, University of Florida. And so she said that it really is beneficial. Essentially, students, she said a few things, and I'll be brief because I know we don't have a lot of time. But effectively, she mentioned that it's great to be able to inform students and parents that if you complete a course at, let's just say, Miami-Dade College with the same prefix in the last 3 digits, the course number, that it will transfer to the other institution. She says it reduces the workload on admissions officers, advisors, and students' transcripts to get back to your student-related question, tend to post with lightning speed, which is what she told me, compared to what she's experienced at another 4-year institution in another state. This also provides the student with timely feedback, so they're not left wanting to know whether or not the courses will or will not transfer. She said it also reduces the burden on faculty. So really all around, it seems like it's just a win-win type of situation, both for the student, but as well as the faculty and advisors.
I just want to supplement that. I think this addition of what Texas has done with the field of study, that makes it engineering relevant courses. So there used to be this core complete notion with the Texas common numbering system, and that used to just be math, science, and the history and the liberal arts, etc. And I think that engineers were at a disservice because they used to finish 2 years, have a lot of unutilized credit hours with the associate's degree. Now they get an associate's degree that is relevant to the engineering degree. So I really like this option.
Yeah, it's common course numbering is not enough. You need to have the right courses to be commonly numbered. So you need to have the statics, the mechanics, the circuits courses. Those have to be available at the institutions. And if they're not, then you have to make some efforts, like we offer those as cross distance education to them. But once we offer them, it's a common course number, and then it automatically goes on their transcript.
And the University of North Carolina system right now is going through a common numbering pathway, because we realized the other colleges in other states had the common numbering. And to ease our transfer, we're starting to shift. We're starting with our biology, our chemistry, and our mathematics courses for common numbering to ease that transition. And then in engineering, what we will do is look at the foundational engineering courses to make sure that they articulate to facilitate the ease of transfer.
Thank you. Another question here. What are your thoughts on having a summer bridge program for students transferring from community colleges to four-year universities? And I'll add on to that, do any of you have programs like that?
Yes, we do at North Dakota. In fact, one of the slides I had showed some students doing surveying, and that's done in the summertime. We bring them to campus for 2 weeks for an orientation. So that really helps them. It's not the traditional sort of bridging program where you learn a course to go forward. We give them a 3-credit course in 20 days, work out the 45 hours of contact time, and give them a little math review. But yeah, we do it, and it's a big part of building that cohort and the interaction between Native students and mainstream.
Yes, I'll add to that. So my former institution, and this is me not speaking as a researcher, but as a practitioner, I was at the University of Maryland, and the Clark School of Engineering, and obviously President Pines knows this, has a bridge program for engineering transfers. And one of the things that I would say it's noteworthy is that it gets down to the specific engineering majors and the courses that are necessary to reduce the time to degree. So as an example, there is an aerospace engineering course without which, and it's not offered at any Maryland community colleges that I'm aware of. And so the reality is if you don't take this one course, you can be delayed by an entire year to your bachelor's degree after transferring. So now this course is offered as part of that summer experience. So a student's time to degree reduces from 3 years down to 2, assuming that everything else works out. So in addition to these individual major specific courses, there are also the things you would expect. So lab tours, meetings with faculty, lunches, getting to know the campus, people finding out where the library is, which is always funny to me that we assume that transfers will know where the library is and they don't. So there's all of that socialization to the campus in addition to the academic support.
As I mentioned in my presentation, a lot of times that fit and the comfort level is really important for transfer students to feel once they get to their new institution. So bringing them in during the summer gives them the chance to get to know campus, work with faculty, take courses, dispel some of their myths or their insecurities so that they can really address it once they start the typical fall semester and hit the ground running and feel comfortable.
We have a bridge program. We don't get much enrollment. The feedback has been that the students need to earn. So they really work and come to school. So we felt the pressure of their finances affecting what would be ideal. So we've moved a lot of what we would have done in the bridge into our first year engineering discovery program. And we keep it open to both. First time in engineering, we call it. Doesn't matter if you're FTIC or transfer.
Thank you. The next question is for you, Bob. How can we scale your programs to grow the numbers of Native American graduates from North Dakota State University who enter from tribal colleges?
That's a good question. I appreciate it. It's a bit difficult because you've got to establish connections. So you work with it, but you can, I've had as many as 40 students at one time, and the idea is to just interact with them and be honest and real. And so you can do that. The numbers aren't great at tribal colleges. I mean, most tribal college enrollments are sub 250. So you're talking maybe 20 students thinking about engineering from their communities. That's okay. Usually we're nationwide, we're talking about 0.1% graduating in Native Americans into engineering. So any amount helps. And when you look at what that can impact on our profession in terms of a different view of a cultural-based view of sustainability and greenhouse activities, I think it's important we do that, make that effort. So, yeah, but we're going to have to work at it a little bit.
Thank you. The next question for Dr. Lester Teasley. On average, 3+2 students transfer to A&T from other universities and colleges each year.
So within our College of Engineering, we see around 20 students that are in our program annually. And I want to say, based on what I've seen in my civil and environmental engineering program, we graduate about 3 or 4 students each year from our specific program.
Thank you. So I think all of our panelists could answer this one from their perspective. What type of interaction would be helpful for students that want to transfer to complete a bachelor's degree? For example, campus visits or social interaction with the engineering college? Why don't I turn that to Bob first?
Yes, the answer is yes, all of those. As much contact as you can do. Let them see what's going on, and let them see professors as individuals and not just some stage on the stage, and let them know that they're real people and they can relate to folks. Talk to them about their activities. I usually get a big set of smiles when I drive up on my motorcycle and they start relating to that, and whatever it takes to let them know you're just a real human and stuff. But I think you've got to make that effort to outreach to them, because if you don't and you just think that it's a common classroom, they have doubts about themselves. I mean, this is a population that has really, in the history of the United States, gone through periods when they were of no value to the country, no value, and in fact, their eradication would have helped the progression of the country in some politicians' views. Okay, that's a pretty tough space to come from. Okay, and I'm sorry if I'm dramatizing it for those that are in the nation, but this is just a white guy's view of the outside. I feel bad about it.
I just want to give a recommendation for the SHIP Junior and the NSB Junior and the SWE have all adopted a very good approach that the students in universities can create alignments with the community college and create junior sections there, as well as with schools. But we found a very good value from that, the student to student interaction. And we recommend and support our own transfer students with hosting and leading those events.
In our college, we use a combination in that we'll invite the students to campus, walk through labs, meet professors, and meet other students. But we also have an open invitation event for community college advisors so that they can come in and meet each of the department heads and talk about the programs and what are the roadblocks that they have. So we spend an entire day working with them. And then the third item that we do is we'll invite both the advisors and the students together, because we're finding out that advocation by the advisors once they go back to their home institution really helps make the students feel comfortable about coming to our university.
Let me add to that. That's crucial that you have the on-site participation, because they get to see the students on a weekly basis, and the mainstream institution sees them on a very drawn out time schedule. So keep it there. I'm sorry to interrupt.
I agree with everything that was said. I guess I'll just add that the financial implications and considerations for community college and transfer students are not trivial. And what I've learned in my research is that, quite honestly, students are going to school part-time, supporting family members, taking on 20, 30 plus hours a week jobs. And this is not the narrative that we hear of when we think about our FTIC first-time freshmen in most cases. And so I think obviously many of us are aware of the NSF STEM grant, but to the extent that we can help to defray the cost of college for these students and to allow them to not have to worry as much about their financial obligations and focus more on school, I think that is clearly something that would benefit everyone.
Thank you. So this is a question about 3+2 programs. So I'm assuming, Stephanie, this one's for you or others that have worked with 3+2 programs. But With 3+2 programs, have you seen students at institution 1 deciding to stay there since they're going into senior year rather than going to institution 2, which is a new environment? And how do you address that?
So with us, we have not seen students that have decided to stay at the initial institution because they want their engineering degrees and they know that they have to come to the 2 portion of their 3. And so we have not had students that have decided not to come to A&T. Now there are other institutions that have 3+2 programs. So if there is that shift, it would be they choose not to come to our university, but go to another engineering program to complete their 2 part of their engineering degree.
You know, I never thought of it as a 3+2, but hearing this, we have with Texas Women's University, they don't have engineering, but they have math. So we offer a dual enrollment. They get both the math degree as well as the engineering degree. They get electrical and mechanical are eligible. We don't have too many, but we have like 5 per year enrolled, and they are just the most stellar students. I think I see them featured on our covers routinely. So so we have, again, they get both degrees, and we put the degree plan. Someone asked a question about detail articulation. We put the 2 color coordinated, we put the TWU colors and the UNT colors, and they have their syllabi for both on both our websites.
And Nika, because the students that come through these programs are absolutely wonderful, and they love their initial institution, but then they learn to love the second institution too, because they specifically want that engineering degree. And with us also, they have to graduate at the same time from their first institution and our institution. And typically they will have a math degree from the first institution and then engineering from us. And the students that go through our program are just absolutely wonderful. I've specifically worked with a number of women who came from Spelman, and I've had a few students that came from Morehouse. And so just having that shift for all women's college or an all men's college and then coming into engineering, it's a really strong dynamic that happens with those 2 students.
And I do see a follow-up comment here from Jane Dorman that says, we've seen students say physics is good enough and give up on engineering. So it sounds like that is a concern at some places where maybe students give up because it's challenging. And so I think that's something that all of our institutions that have these types of programs will make sure we need to continue working on. The next question, is it possible in a given state to map large articulation agreements between 3+2 programs down to the syllabus and curriculum level to ease access and barriers? And maybe I'll add to that also just even from community colleges as well, without necessarily having to be a 3+2 program.
The Common Core does that. The syllabi are first shared and voted on, and then all the mechanical engineers agree that this is the common topics that will be covered. So those are, that's with the field of study group of courses. So electrical, civil, chemical, and mechanical have those.
I can confirm that's a helpful thing, because we have the common course numbering, but we don't have the field of studies. And that sort of gets a conflict, because they'll take courses and we'll have students that have an associate's degree, but they have to go back and take some fundamental engineering degrees to be able to move forward. So they have to go back and take the statics and do some other degrees that they didn't realize was part of the program going forward. That's one of the things we tried to eliminate.
Yeah.
Okay. So I have a comment or a question that I'm going to pose to each of you and let each of you have a chance to answer. So what do you see as the most compelling inequities in the transfer process that need to be addressed and maybe addressed immediately? Let's start with Brooke.
Wow. You know, there's another population that we don't talk about when it comes to community college transfer, and that is the students who test into developmental math. So typically when we think about the engineering student, it's a student who's coming in with pre-calculus or calculus readiness, whether they're community college or 4-year. And the reality is a lot of students, and particularly students of color, coming in at developmental math levels will not even attain to calculus, let alone earn an engineering degree. And I think that's a real issue of access that we need to think about and how we can bridge the gap. I'll make a quick plug for my colleagues at the NSF includes Alliance-funded program STEMcorps, stemcorps.org, who are doing great work in this space. So just trying to move students along that pathway would be a tremendous benefit to democratizing engineering.
So I echo Brooke highlighted a very critical point. So what we've done is we've done the algebra degree plans. They don't even know that it is whether we've judged them in one way or the other. We found that to be very popular. It shows up on our most frequently clicked links in our website. The algebra pathway, pre-calculus sometimes, but algebra, that's it. You just kind of start with algebra. And the dual enrollment option has resonated very well. So in my perception, the inequities are really in getting the information directly to the student. We've hosted the transfer advisors. We've learned that there is a different level of hierarchy within the community colleges, multiple campuses in Dallas, that we really can't get the information to the students. So anything that would allow the student to directly receive these dual degree plans, start out in algebra, could help. And maybe the silver lining of this COVID world was the Zoom information sessions that we were able to reach 8th graders and above to let them know about that. This is the degree plan if your destination is a degree in engineering.
So I would say compelling inequities to address some of the concerns would, of course, be the math placement, making sure that students that want to become engineers are on the right track for their math preparation, but also thinking about non-traditional students who are older, who worked, who are military veterans that are coming back. A lot of times they're not there for the same college experience as younger students. And so being able to help them quickly move through your programs, consider the types of sense of belonging that they need and the help, because they really want to focus. A lot of times they have families, and so they don't have a lot of time to waste when they're in these programs. So clear articulations, plans of study, and helping them move through the programs, especially if they start at a community college and they're truly trying to finish their degrees in 2 years.
Just to quickly add, beyond the academics, the cultural blending into the new institution is hugely important. I've seen students leave for not for academic reasons at all, just because family, spouses, all kinds of things.
Thank you. I'm trying to determine if we still have time or if we're actually out of time. So I'm not quite sure. Let's see. I think if there was any last point that any of you would like to make sure that we address today, I would like to open it up for that. And we do have a little bit of time here. So so maybe what I'll do, actually, maybe I'll ask one more question and then I'll give you the chance. So that gives you a minute to think through if there is something you want to say. So the next question, when we were all discussing and we all got together last week, one of the things that came up was, how do we restructure engineering to meet the learner where they are? And so Bob, maybe I'll turn it over to you to see if you have any thoughts about how we could restructure engineering.
The first thing is that we have to understand we're not going to drop criteria. We're not going to make half qualified engineers. They got to be fully qualified. There are important issues out there, and we've got to do that. But on the flip side, we don't have to use intimidation. We don't have to pile on the work. We don't have to just sort of blindly assign things to them without letting them know that there's some support. I think the most gratifying thing I saw was students helping students get through problems in classes. I had one of my Native American students teaching another Native American student dynamics, and he had learned this at a tribal college from one of our mentors, a Purdue graduate actually, PhD in astrophysics, was teaching dynamics to him, and he was helping another student go through it. And that's the kind of thing that drops the intimidation level. We don't need to drop the quality level, but we do have to drop the intimidation level.
So I think there's two parts there, which is I look at it as, looking through the ABET accreditation requirements. Definitely you look at mechanical, electrical, civil, there's no problem with the prerequisites of math fitting the learning outcomes of subsequent classes. But I looked at information technology, etc., and it's almost like the math is almost secondary to the learning in computer science. And so there's kind of a need for ABET to revisit where math is actually relevant to prerequisite knowledge and where it isn't. On the other side, what I found is there's definitely a huge market for people who have vocational skills, who can still develop the managerial knowledge and the project management, etc. So we have grown something we call the Bachelors of Applied Arts and Sciences. And we've created applied technology and applied computing 24 credit hours of engineering courses that are more vocational in nature, but still lead to a very good job. So it could be machining, CNC, CAD, etc., don't require calculus. And so I think the synonymous use of calculus being an engineering requirement for learning is probably at the root of the problem.
And I think to help reform engineering, we're coming off of a pandemic. And so I think our students want different learning options now. And so as educators, we need to start thinking about what's in the best interest for our students. What do they really want for their learning experience? And how do we infuse engineering so that it's really creative and innovative so that the students are engaged? I think a lot of us, are used to traditional engineering pathways, but we need to start looking at innovation, entrepreneurship. How can we inspire the students that are now in front of us to learn remotely, to learn in person, and then take their ideas to apply it to that shift that we might need? Hopefully we'll never go through another pandemic, but thinking creatively and understanding that things aren't predictable, I think is another thing that we need to start infusing into updating our courses that we're teaching.
Again, agree with everyone so far. I'll just add this, that quite oftentimes when we think about connections and partnerships with community colleges, it's oftentimes framed as a unidirectional four-year college will help the community college that needs more support kind of a framing. And we typically don't ask the community colleges how they can help the four-year institutions. And the reality of it is that they know these students very well. They've worked with them, their families, their finances, they know their context. And so I would love to see an environment where community colleges are asked to come to the table more when we talk about expanding participation in engineering, we talk about mentoring, when we talk about support, and let them sort of lead these conversations and bring them more to the table. Thanks, Robert.
That's
Thank you.
That's absolutely true. You got to do that. That's what we've done.
So we just have just a very short amount of time left. If you want to take 10 or 15 seconds to give us either a takeaway or your last word on this 3+2 and transfer pathways, what would that be?
It's $1 million question. I think let's just keep working hard and be open-minded.
I think flexibility is a good thing. So if we come to the table with presuppositions of what defines success, we almost lose the potential of what could be innovative that can emerge from conversation.
I think thinking about what is in the best interest of our students, both culturally for diversity, inclusion, and how do we best support them when they're transferring into our institutions is vital.
There are things that a community college can do that we just can't afford to do in a mainstream institution for the student.
I want to thank you all very much. I think this was a really insightful conversation, and thank you for all the work that you are doing for students at your institutions and at other institutions as well, and partnering with other institutions. So thank you again for sharing your work. I want to make sure that everybody remembers to please provide feedback on the whiteboards in the lobby. Some instructions will be posted about how to do that. There will also be a single feedback question in Poll Everywhere, and the link will be posted as an announcement that will pop up on your screen. That allows our evaluators to understand what you all are taking away from this. So please do take a little bit of time to give feedback on the whiteboards and the Poll Everywhere.